This video will focus on soil texture, which relates to the components of soil that influence its physical and chemical properties. Soil texture is the relative proportion of soil separates, sand, silt, and clay. It is a basic, permanent, and static property of soil and cannot be easily changed or altered. The first method for determining soil textural class is the feel method. By rubbing moist soil, we can identify sand as gritty, silt as talcum powder when dry, and clay as plastic and sticky when wet. The second method is the laboratory method, which involves mechanical analysis and the use of the textural triangle. Mechanical analysis determines the sand, silt, and clay contents. This process involves pre-treating the soil to remove large rocks, organic matter, carbonates, oxides, and soluble salts, followed by dispersion. Mechanical analysis involves dispersing particles and separating them. Particles larger than 0.05 millimeters are separated by sieving, and smaller particles by sedimentation. Methods include the International Pipette and the Buyukos hydrometer methods. The International Pipette method is based on sedimentation following Stokes' law. It is a standard method with high accuracy but is time-consuming and not suitable for a large number of samples. The Buyukos hydrometer method, developed in 1927, measures the continuous decrease in soil suspension density over time. It is faster and reasonably accurate, but it's not ideal for soils with high content of calcium carbonate, organic matter, or salinity. Stokes' law describes how the terminal velocity of a spherical particle settling in a fluid is proportional to the square of its radius under the influence of gravity. One assumption of Stokes' law is that particles must be spherical, smooth, and rigid. However, clay particles are often plate-shaped and fall slower than predicted for a sphere of the same mass. This image illustrates Brownian motion. Another assumption of Stokes' law is that particles must be large enough so that Brownian motion does not affect their falling velocity, which is about 0.0002 millimeters. Smaller particles can be separated using a centrifuge. The fall must be unhindered. High concentrations or closeness to the container walls can slow particles. A soil concentration of less than 3% in suspension is recommended to reduce these hindrances. Particles must also be of uniform density. The density of most mineral particles in soil averages 2.65 grams per cc, which is used for accurate results. Finally, the suspension must be still, without any turbulence, and there must be no slipping between the particle and the liquid. Particles larger than 0.05 millimeters can cause turbulence. Limitations of sedimentation methods include the actual shape of particles, the necessity of maintaining a constant temperature, and the specific density of soil particles. The textural triangle is used to classify soil based on the percentages of sand, silt, and clay. For example, a soil with 40% sand, 40% silt, and 20% clay by weight is classified as a loam. There are 12 textural classes based on the relative proportions of sand, silt, and clay. Soil textural groups include sandy, loamy, clayey, and silty soils, defined by the proportion of their separates by weight. Sandy soils are loose, well aerated, drain quickly, and are easy to work, making them light soils. However, they have lower water and nutrient holding capacity and are susceptible to wind erosion. Loamy soils are considered ideal for crop production, exhibiting balanced properties of sand, silt, and clay. They have better water and nutrient retention than sandy soils and favorable drainage compared to clayey soils. Silty soils are medium textured, offering medium to high water and nutrient holding capacity and moderate aeration. They are susceptible to erosion and compaction and become moderately difficult to till after rain. Clayey soils are fine textured, characterized by high water and nutrient holding capacity. They are cohesive, difficult to cultivate, and resist erosion when aggregated. They also have good sealing properties and slow drainage. It is worth noting that clay soils are lighter in weight than sandy soils when comparing equal volumes. Sand and silt consist mainly of primary minerals like quartz. Clay particles are secondary minerals, such as kaolinite. Clay is highly surface active, unlike the more inert sand and silt fractions. Specific surface is the surface area per unit mass or volume of soil. As soil particle size decreases, the specific surface increases. A greater specific surface enhances the soil's capacity to hold water, retain nutrients, release plant nutrients, promote particle aggregation, and support microbial colonization.